Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड ईयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई और MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक करदेव और चैनल को सब्सक्राइब करदेव यू कैन शेयर इट विथ योर फ्रेंड्स ऑल्सो इट्स कम्प्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन बेल आइकन को ये ऑल सेट करदेव तापर वीडियोज क्लारिटी बढ़ाई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज PDF नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें जनरल मोशन ऑफ ए रिजिड बॉडी ए विषय रे पढिबा ऑलरेडी तमे रिजिड बॉडी विषय रे देखिलो जनरल कोऑर्डिनेट्स हमें देखिला जे it needs 6 independent coordinates to describe its complete configuration okay तापरे ए रिजिड बॉडी रो जो जनरल मोशन या विषय रे तमे ऑलरेडी प्लस 3 रे मैकेनिक्स रे पढी देबो रिजिड बॉडी एक्चुअली हमें जेमति देखिला इट इज मेड अप ऑफ अ नंबर ऑफ पार्टिकल्स सच दैट तांको भितरे रिलेटिव डिस्टेंस फिक्स्ड बा कांस्टेंट रहउतबो ओके तापरे जेतेबेले आमे मोशन कथा कहबा गोटे रिजिड बॉडी रो एक्चुअली टू टाइप्स ऑफ मोशन एक्चुअली दीज आर इन्वॉल्व नंबर 1 इज ट्रांसलेशनल नंबर 2 होची रोटेशनल सो ट्रांसलेशनल को आमे लीनियर मोशन मध्ये कहि परिबा वेयर all the constituent particles of the body move along parallel straight lines and they undergo equal displacement in equal interval of time that means velocity of every particle of the moving body will be constant or same at any time okay hence the same linear acceleration for every particle आ जो ट्रांसलेशनल मोशन अच्छी एटा होची गोटे प्रोग्रेसिव मोशन एंड every particle is equally affected in determining the motion of the body okay so moving body in this case may be treated as a single particle okay पूरा whole body को हमें गोटे single particle भलिया treat करि परिबा and the entire mass being assumed to be concentrated at the point जाको कि हमें कहबा center of gravity of that particular body so such type of motion may be produced or altered by a single force which is acting upon the body or a set of forces equivalent to a single force. Now you see here in the figure we have considered a body which is undergoing a translational motion from position A to position B such that एठी हमें चारिटा particle नोचो P1 P2 P3 and P4 such that they are displaced by equal distance that is suppose delta x okay a very small distance but equal distance delta x in a small interval of time that is delta t okay ताले एबे यार velocity यदि हमें देखिबा as delta t tends to 0 ताले limiting value हिगला velocity रो delta x by delta t okay and it will be called as the instantaneous linear velocity v at any instant of time t okay so हमें यदि लिमिट लगेला ताले it will be the complete derivative that is dx by dt similarly linear acceleration हमें बाहर करि परिबा a equal to dv by dt which will be d square x by dt square so ये गला translational motion तापरे एबे देखिबा rotational motion so rotational motion नारु जोना पडुची here the body will be rotated about some fixed axis and each particle of the body describe circles having center on the particular fixed axis okay so different constituent particles of the body will have different linear velocity जोटा कि रहिबो along the tangent okay and although angular velocity रा समान रहितबो किंतु linear velocity रा अलगा अलगा हे जिवो rotational motion रे okay so rotational motion होची गोटे जदि हमें देखिबा in a stationary object can be produced or altered by a couple which is acting upon the body or a set of couples equivalent to a single couple okay so you see now in the figure here एठी पोजीशन A रु पोजीशन B को जाउची ओके it is representing a rotational motion of a rigid body. Okay, ଆଉ ଏଠି fixed axis ଆମେ ନଉଛୁ ଏଇ ଯୋଉ point ଅଛି O. Okay, so the axis is passing through this point O and being perpendicular to the plane of the paper. Okay, ମାନେ ଏଇ ଯୋଉ screen ର plane ସାଙ୍ଗରେ perpendicular ଅଛି axis ଟା ଆମର. Okay, suppose different particles ଆମେ ନେଲା like P1, P2, P3. Okay, and they cover now unequal distance. As you can see, P1 ରୁ P dash, or sorry, P1 dash, then P2 to P2 dash, and P3 to P3 dash. So distance ଏଠି unequal ରହୁଛି, କମ ବେଶୀ ଏମିତି ଆସୁଛି ହେଲା. So in the same interval of time, you see the points are covering unequal distances. ତେଣୁ କରି linear velocity ନିହାତି ଭାବରେ ଅଲଗା ହେବ. But ଯେହେତୁ ଏଇ small interval of time ରେ ଯଦି ଆମେ angle ଟା ଦେଖିବା, okay, as you can see in the figure, ଏଠି ଯୋଉ angle create ହେଉଛି it is same. Okay, that means angular velocity ଟା ଏଠି ସମାନ ରହୁଛି. Okay, in the small interval of time, that is delta t, they all rotate through the same angle delta theta. Hence angular velocity will be same for each particle of the body, and its limiting value is delta theta by delta t, and as del t tends to 0, it will be called as the angular velocity, which is given by, যদি লিমিট লগাইবা তাহলে d theta by dt into omega cap, এটা হলো তার unit vector. Okay, which will be determining the direction of angular velocity, and this will be the magnitude, right? So similarly now angular acceleration ଆମେ ପାଇ ପାରିବା, which is nothing but the rate of change of angular velocity, that is d omega by dt. याको ଆମେ alpha बोलिकी लिखिथाउ. Okay, এটা তুমি plus 2 ରେ भी पढ़िथिबो. Okay, so let us move further. Now you see the rotation about a fixed axis. Okay, या विषय रे मैं डिटेल जाउनी. देखो एठी फिगर रे हमें गोटे रिजिड बॉडी नउछु which is rotating with some angular velocity, that is omega. Okay, about a fixed axis. Here this is our, sorry, this is our fixed axis, right? Now this axis is passing through this point O, and each of the constituent particle of the body moves in a circular path having its center on the axis of rotation. Suppose ame gote ethi point nela P, which is at a distance r from the point O. Tale r hegala ethi position vector ei observation point P ro. Now ei point P re suppose gote ame negala mass, that is small m relative to O, then its linear velocity will be given as v equal to omega cross r. Actually रे एठी या ऊपर भी एरो मार्क पड़िबो, वेक्टर अछि या ऊपर भी एरो मार्क पड़िबो. ओके, ताले एटा आसला रिलेशन linear velocity और angular velocity भितरे. So it is the tangential, actually ए जो linear velocity टा जेमति कहली, it will be along the tangent. So it is the tangential to the circular path described by the particle P and perpendicular to the radius vector r, because cross product अछि. Now since small m तमे mass नेथिलो particle रो at the point of observation P, so its linear momentum will be mv, P equal to mv. Hence its angular momentum केते हेबो, निहाती भाबरे r cross P, that is angular momentum. देखो एई बही रे एटा jp लिखिछि, केतेटा बही रे याकू कैपिटल L लिखा हिता, L equal to r cross P बा r cross mv. ओके, एठी भी एरो मार्क लागिबो, m ta scalar. Okay, so its direction will be perpendicular to both r and v. Okay, therefore total angular momentum j of the whole rigid body will be the vector sum. So vector sum hame bahar kar dela ei hisab re. Okay, and the direction of this total angular momentum j will be in general not coinciding with the direction of angular velocity omega. So further याको expand करले এই relation हमें पाउछु, that is summation m r square omega minus r dot omega into r. Okay, या विषय रे हमें डिटेल आकु पढ़िबा. Okay, से जहाँ भी हो एटा फर्दर कैलकुलेशन कराई जोथिरे कि हमें मोमेंट ऑफ इनर्शिया पाउछु. तमे जानिछो मोमेंट ऑफ इनर्शिया माने समेशन ओवर m r square. Okay, मोमेंट ऑफ इनर्शिया गोटे रिजिड बॉडी रो अबाउट अ गिवन एक्सिस ऑफ रोटेशन. सो एठी एंगुलर मोमेंटम को हमें लिखि परिबा एज द प्रोडक्ट ऑफ moment of inertia and the angular velocity. Okay, so the component of angular momentum along the axis of rotation will be the product of I and omega. Okay, now we suppose that the axis of rotation is also the axis of symmetry of the body. তাহলে total angular momentum J এই বডির ହେଇଯିବ will be in the same direction as the axis of rotation. Okay, so finally we'll get J equal to I omega. Thus total angular momentum about the axis of rotation will be equal to the product of momentum inertia about the axis and the angular speed. Similarly, the moment of force, that is nothing but the torque, will be given as the rate of change of angular momentum, that is dj by dt, and this will be finally equal to the product of moment of inertia and angular acceleration. Okay, acha. So এই হিসাবে আমি দেখলা general motion of a rigid body, up to which I have taken it from one book. Okay, now further I have taken the same thing, the general motion of a rigid body, from internet. You can see these are some of the useful slides. Same ଜିନିଷ general motion rigid body ର ଦୁଇ ପ୍ରକାର, ଗୋଟେ translational ଗୋଟେ rotational. Okay, so ୟାକୁ ଇଏ shortcut ରେ point wise ଦେଇଛି, so you can read out these slides also and take the useful points. Now further the same thing, general motion of a rigid body, I have taken from another book. Okay, so ଏଠି ଦେଖ translational ଆଉ rotational motion को again ଏଇ ବହିରେ detail way ରେ ଏଠି ଦେଇଛି. Okay, so you can read from this book also, and by combining from all these you can make your note accordingly. Okay, so this is all about the general motion of a rigid body.
Thank you.